The summer of 23 burned itself deep into my memory, not just because of the relentless heat waves smashing records worldwide, but because it forced me to rethink everything I thought I knew about energy. I'm a seafarer engineer, someone who spent countless hours around ships powered by natural gas and LNG, watching those steady blue flames on the engine room burners. For years, I believed LNG was our climate's ally. A cleaner bridge fuel, the stepping stone between dirty coal and the promise of renewables. But that summer made me question this comforting story. The allure and the trap of the bridge fuel. When I first heard LNG called a bridge fuel, it made perfect sense. Imagine a world scrambling for energy security amid wars and crises like when Russia invaded Ukraine, and suddenly LNG was everywhere, praised as the cleaner alternative to coal and oil. Governments invested billions in terminals, shipments surged, and the narrative was simple. LNG would buy us time, bridge us to a renewable future. But here's the catch. This bridge is leaking methane, a gas far more dangerous than carbon dioxide. Methane slip is the term for methane that escapes throughout LNG's journey, from extraction deep in the earth to the flame burning in your kitchen stove. And methane packs a climate punch that CO2 can't match. Over 20 years, it traps 80 to 86 times more heat than carbon dioxide. Even tiny leaks, just 2 or 3%, can erase LNG's climate advantage over coal. Imagine that. The very thing we trusted to save us from pollution could be making things worse. Tracing methane's invisible trail. Let me walk you through LNG's journey, something I've seen firsthand aboard ships and at terminals. It all starts underground at gas wells, where methane leaks out from valves and pipes, sometimes in invisible wisps that add up over time. Next are compressor stations and processing plants, each a potential leak source. Studies say these upstream leaks make up to 40% of LNG's total climate footprint. Then comes liquefaction, the process chilling gas to minus 162 degrees Celsius to turn it into LNG. It's a high-tech operation, but also surprisingly leaky. Pumps and compressors can't seal every escape route. After that, LNG is loaded onto massive carriers for sea voyages. But these ships suffer from boil-off gas, slow evaporation of LNG that, if not captured properly, releases methane straight into the atmosphere. Finally, when LNG reaches its destination, it's converted back into gas and piped to homes and businesses. Even here, tiny leaks from pipelines and appliances add up. Across every step, methane sneaks out unnoticed, making the whole supply chain leakier than most people realize. The problem with average numbers and hidden super-emitters. One of the biggest shocks, official reports on methane emissions are often based on averages or estimates that miss the worst offenders. New tools like satellites and drones reveal super-emitters, a few facilities responsible for massive leaks that dwarf typical levels. I remember seeing satellite images of one single gas site in Texas, sending out a methane plume so huge it was visible from space, undone years of progress in one blow. It turns out we're only about 5% of the way toward truly understanding methane emissions globally. That's a huge blind spot with massive consequences because methane's warming effect is so potent. When LNG looks dirtier than coal. Here's where it gets really surprising when you factor in methane leaks. Burning LNG can actually produce more greenhouse gases in the short term than coal or oil. LNG emits less carbon dioxide per megawatt hour than coal or oil, but leaks enough methane that its overall greenhouse gas footprint can be higher than coal's. This flips the whole clean bridge story on its head. The risk of betting big on leaky infrastructure. Since 2022, with energy crises sparking urgent demand, billions have poured into new LNG terminals and export capacity. Plans are underway to triple global LNG exports by 2030. But here's the dilemma. These investments lock us into decades of fossil fuel use, potentially stranded assets if renewables outpace LNG demand. Every dollar spent on new LNG risks delaying the clean energy transition we desperately need. It's like buying a fancy new car but filling it with dirty fuel. It looks like progress but doesn't solve the root problem. Fixing the leaks, technology, and policy aren't optional. The good news? We have tools to detect and fix methane leaks, satellites, drones, real-time sensors. Leak detection and repair programs can target super-emitters before they become climate disasters. But technology alone won't solve this if governments don't enforce strict standards. Voluntary pledges fall short without mandatory reporting and real accountability. Methane needs to be treated as seriously as carbon dioxide, using its true climate impact over 20 years. As one expert said, you get what you inspect, not what you expect. The final lesson, betting on truly clean energy. My kitchen stove still has that blue flame of natural gas, a daily reminder of how easy it is to settle for cleaner rather than truly clean energy. But chasing incremental improvements in fossil fuels like LNG won't get us where we need to go. The hidden methane leaks threaten our climate goals and risk locking us into a high-emissions future. The real path forward is investing boldly in solar, wind, batteries, the rapidly advancing technologies that are truly clean and sustainable. The bridge built from LNG might look solid on paper, but it's riddled with cracks too dangerous to ignore. It's time we stop optimizing fossils and start embracing energy solutions that actually protect our planet for generations to come. And that is why the story of LNG and its hidden methane mysteries matters so much.